Welcome back to the second part of Just Enough Unity. This time we're going to talk about visual scripting, which is a way for you to write code in Unity without actually having to write code. But for those of you who are computer science students in the class, feel free to keep watching this because it will talk about some of the functions in C# that the visual scripting components correspond to. So it's still worth watching this video. So in a nutshell, visual scripting basically means making games without coding or making programs without coding. Previously, it was a tool that was in the asset store called Bolt until Unity basically bought the company, and now it's integrated permanently into Unity. So this website actually has a little more detail about how to do visual scripting and a bunch of deeper tutorials as well that you may want to take a look at. So basically what you do in visual scripting is that you are taking the output of nodes and you're feeding it into the input of other nodes. So this is a very simple example of a visual script. And these, as you can see, are nodes. This is the transform position node. This is the vector 3 get node, less than function node, branching node. And basically, you take the outputs of one node, you feed it into the input of the next node, and so on. This particular line here, this white line that feeds this node to this node, and then this node to this node, what distinguishes this line from these other lines, these other colored lines, is that this one determines the flow of control, which means it determines the direction the program is running. It goes from this node, and then it executes this node, and then it executes this node. This other branch here are essentially doing calculations to feed inputs into these main flow nodes. And when in Unity, you'll know you have the right nodes connected to each other because Unity helps you by only allowing you to connect nodes that are allowed to connect to each other. And it does so by showing you icons so you can see which ones are compatible as well as color coding them. Okay, so how do you get started? Since visual scripting is built into Unity already, what you have to do is simply select a game object that you want to embed a visual script into, because visual scripting is essentially a component of a game object. So to add something, you basically go to the component menu, visual scripting, and then select script machine. Now there's other more powerful things like state machines as well that visual scripting provides, but we'll cover that in another video someday. And so, as I say here, add a script machine or a state machine component to the game object. We're going to focus only on the script machine for now, and then you edit the script machine or the state machine for the game object. And a game object can have multiple script machines, just like a game object can have multiple scripts. And actually, you can also have script machines and scripts all in the same game object if you like. And then you repeat these steps, and then you can actually build out your entire game entirely using script machines if you like. I've done this already just to prove that it can be done. So it is very, very powerful. Okay, let's talk about some basics before we actually dive into each of the nodes and what they do. As I mentioned before, visual scripting is done by creating script machines. Previously, if you watch some other YouTube videos, you might hear them being called as flow machines. That's because in the old vernacular, in Bolt, script machines were called flow machines. And these script machines are assigned to components, to game objects. I also just mentioned that the script machine can be reused in multiple objects. And each script machine also has variables, just like standard C# scripting variables. And then lastly, finite state machines can also be created in a manner similar to script machines. And it makes it really easy to make very simple artificial intelligence for your games. But we'll cover this later. Okay, now in the previous video, I showed you a simple script to take the cube and spin it along the x-axis, right? And so just a quick recap, the code was pretty simple. You had a variable called speed, and you set it to some speed like 1, and then within this update function, this function is called by Unity every single cycle of the game object, and you say game object dot transform dot rotate, and that rotates the cube along the x-axis by this much speed, and then nothing on the y-axis and nothing on the z-axis. So let's look at this in the context of what it would look like for a script machine. So here you see the start function. We don't do anything with the start function. And likewise, Unity has a start event in the script machine. Again, we don't do anything with it, so there's nothing coming out of it. However, we are going to do something with the update function. So the equivalent of that in the script machine is that you have an update event. And notice that I want to rotate based on speed 0, 0. Well, let's look at this transform node, which has a rotate capability. And we've got X angle, Y angle, and Z angle. And what I'm going to do is take a variable called speed in the script machine, and I feed its output into the X angle input. And that's it. This correlates exactly with what we're trying to do right here. Okay? So, this is what we're going to try and cover. We already covered understanding the general workflow. Importing a 3D object, I'll point you to another video to look into. But what I'd like to introduce you to is how to move the object, translate it, in other words, position it, rotate it, scale it, control the object under user input, dynamically create an object, destroy an object, check for collisions between objects, and some physics control. This finite state machine stuff we'll cover in a different lecture. But if you think about it, these fundamentally are the minimum set you need to know for just about any game engine that you're trying to learn. So even if you transition to a new game engine like Unreal, you try to figure out how to master these main pieces, and you're basically on the right course. Okay, before we go any further, I'm just going to show you click by click how to actually make the same application that you saw previously, where you take a cube and you spin it on an axis, but do it entirely through visual scripting. So let's start a new project. New project, make sure it's 3D, make sure you're using the latest version of Unity, 2021 and beyond. Give it a project name, we're going to call it class Bolt Spinner. Let's also make sure that the it's in the right place, in the usual Unity projects folder. Create the project. Let's go. It's going to take some time to load. Okay, let's bring it back into view. Unity's all loaded up. So let's make a cube to start with. We're going to make this cube spin using visual scripting. So let's take a closer look at the cube, click on it, and we're going to go to component, and we're going to add a visual scripting component, a script machine, right there. And then click on New, give it a file name for the Visual Script, save it, click on that, and also give it a title. So let's call it spinner or spin and an object. Let's edit the graph now. Okay, let's make the script machine window a little bit bigger. Let's make some variables, or at least make one, call it speed. And we're going to give it a type. Speed, we're going to give it a type of float. And let's set some default value of 1. Okay, let's bring up the menu by right mouse clicking. And let's just type in speed. And we're able to extract the speed object. Now we're also going to search for rotate. And we're going to look for the transform rotate node. This one will do. And now we're going to feed the output of speed into the input of the X angle in the rotate node. Now you also have to connect the on update to the transform rotate node. So that way, whenever there's an update at every cycle, the rotation will be affected by the speed. So let's play the animation or the program, and you can see it's spinning. Just like the scripting version, the old scripting version I showed you earlier, if you change the speed variable here, it'll speed up, or you can slow it down by dialing it down to something like 0.1. Okay, let's go look back at the state machine, script machine for a moment. Notice there's a little bit of animation going on. You can see Unity is animating what's actually happening between the script nodes. This is a really useful debugging tool, because if you ever see any of those links turn red, that means there's a bug. There's a break in your code. Let's also try connecting speed to the Y angle. In other words, we're going to rotate in the X and the Y axis at the same time. Run the program. And now you see the cube is now spinning in both the X and the Y axis. And if you look back at the script graph, you can see again the animation demonstrating how the script graph is working. Welcome back. Let's go through each of the primary nodes that I just mentioned in the previous slide. Here, for example, we've got move the object. We want to be able to position it, translate it, rotate it, scale it. So in Unity, the node that you use for absolute position of an object in space, in X, Y, and Z, is the transform position set node. You're setting the values. You can also retrieve the absolute position by simply saying transform position get. Okay. In the previous video, you probably saw how you actually find these nodes, right? So refer back to that one if you've forgotten. But this node, for example, is the equivalent. Using this node is the equivalent of saying GameObject.transform position equals setting it to a vector of 3 values, x, y, and z, right there. If you want to translate something, in other words, move something relative to its current position, in Unity use the transform translate node, and this is what it contains. And again, you fill it with x, y, and z, but instead of moving to an absolute position in space, it moves it from its current position to a new position by a certain amount. It translates it. It kind of slides it along. And so in terms of raw C# Unity code, this is what you would write. You would say GameObject.transform.translate, and then your x, y, and z as a vector 3. Okay, let's look at rotation. I'm going to show you the relative rotation first. In other words, your object is rotated a certain position, a certain orientation, and then you want to rotate it just a little bit more relative to its current rotation. So to do that, you use the transform rotate node, and you can give it rotation around angle for x, y, and z. These are what we call Euler angles. Here's the equivalent C# function, GameObject.transform.rotate, and then you give it the angle. In this case, just 0, 0, 0. Okay, now rotation for an absolute angle is a little more involved. The fundamental node is called the transform set rotation node, but you can't just feed it with rotation in x, y, and z. Because what it accepts is what Unity calls a quaternion. A quaternion is a way of representing orientation with 4 numbers rather than 3 numbers. So, however, Unity also provides a node that converts from Euler, which represents orientation in 3 numbers, into a quaternion that represents numbers in 4 numbers. So you can use this quaternion Euler converter node, and whatever 3 numbers you type in for rotation around x, y, and z will be converted, and then you can feed that output into the input of this node. Just like the translate and position node, you have functions or nodes that let you get the current transformation, current rotation of the object using the transform get rotation node. Okay, scaling. Scaling is pretty easy, and it's very similar to what you just saw with the position node. You can say transform local scale get to retrieve the current scale of the object, or you can set the scale. Set the scale by saying transform local scale set. So use that node to do that. Here's the equivalent code. You would say GameObject.transform.localScale equals new vector, and then whatever the scale you want to scale at. So along the x-axis, along the y-axis, along the z-axis. And by the way, this is the documentation in the Unity reference manual that explains this function. Okay, how about user input? Let's say you want to press a key, like the space bar. How do you do that? Well, Unity also has a user input node, a on-keyboard input event node. And from this menu, you can select the specific key you want to check, and you can also specify the specific action, like whether you've just pushed it down or you've released it, and so forth. And so in this particular example, this would be the equivalent C# code, input.get key down, and then the key code .space to represent the space bar that you're checking for. There's a great YouTube video you can watch that also explains some of this, so take a look at that if you're interested in more details. Also, you can get the input axes, and what I mean by input axes is that whenever you're doing joystick control, you have both a vertical and horizontal input axis, and generally this retrieves a value between 1 and -1, depending on how far you push the joystick in any particular direction. The equivalent C# code would be, if you do input.get axis And then vertical, that means you're taking the value for the vertical axis, right? You will do something else with it. Okay. Okay, conditionals. Conditionals basically means how do you get Unity visual scripting to do something like, if something happens, do something. So in this particular example, if I say if the z value of an object's z position is less than -10, destroy itself as an object. So this would be a very typical piece of code you write where, let's say you're writing a simple infinite runner, and in an infinite runner, objects are constantly coming at you. But if the objects are going behind you past a certain point, you want to get rid of them, you want to destroy them. So the z value is the z direction in the 3D world. So if that z value of the object is somehow less than -10, in other words, behind you, then you want to destroy it. So how do you do that in visual scripting? Well, first, let me show you how it's done in C#. And so in C#, it's really simple. You say if the game object's position, z component of the position, is less than -10, then you can say destroy the game object. In visual scripting, it's a little more involved, but it's still pretty simple to understand. So what you do is you take the position of the game object. So transform position get. Self means yourself as the game object. You feed its positional output into this vector3 get z node, and all that does is extract just the z component. So like this, the dot z. And then you feed it into this less than node, which is basically trying to compare if A is less than B. So in this case, A is the position, B is -10, because we want to check if the z value is less than -10. In other words, if the A here is less than -10. You take the output of this and you feed it into a branch node. And so if this condition happens to be true, then this branch will proceed to do this next step. If this turns out to be false, I've got nothing coming out of the false, so it's not going to do anything. Okay? And so this last node will get invoked whenever this branch is true, and this node happens to be destroy. And what are we destroying? You're destroying yourself, the game object itself. So you can get a self node and you can feed the output directly into the object that you want the game object to destroy. So that in a nutshell is how you do conditionals like if statements. And you can create much more elaborate conditionals by just creating a whole cascade of these different branches and conditionals. You can do greater than, equal to, and so forth. Quickly, I want to say something about variables in visual scripting. So in C#, basically, you're dealing with variables all the time as well. Public variables in your script expose themselves in the inspector, so you can change the values when you're using the inspector view, which is a kind of cool feature. In visual scripting, there are a bunch of different types of variables. One of them is called a scene variable. And what that means is that that particular variable is shared throughout the entire scene. So every game object and every visual scripting script has access to this same variable. There are also graph variables, which are shared among all script graphs of the same type. And most of the time, you'll actually be dealing with object variables. Everything you've seen so far has been dealing with object variables. And they're only accessible to the individual game object that the script graph is attached. There are also things like app variables. Basically, they're variables that are shared among all the scenes in an app. So let's say, for example, you're making a game that has multiple levels of a game. Typically, a level of a game is stored under one scene. But let's say your player score is one. You want to carry the player score between each level. Well, if you make the player score an app variable, it will automatically be accessible in every new scene, so you can keep adding to the score as the player improves. Lastly, there's also saved variables. And basically, these variables get automatically saved to disk and restored when you're quitting the game, for example, or when you're loading the game for the first time. Okay, I talked a little bit about the conditionals here, right? Less than and so forth. Sometimes you want to write little equations. You need to do some calculations. Unity has a bunch of nodes for adding, dividing, subtracting, but it can get kind of tedious to string up all these nodes just to do a very simple math equation. So the easiest way to do it is create what's called a Unity a formula unit. And this is what the formula unit looks like. And inside, you basically specify how many inputs this formula is going to take, A, B, C, 3, in other words, and you can just type whatever mathematical formula you want in it. So here in this case, it's A times B plus C is the formula I sort of made up. Okay, here's a quiz for you. What does this do? Well, let's look at it. So we've got, here's the onUpdate event, right? This is what is going to run every time this game object is running in the game. This visual script is running in the game. And what it does is that it takes input via get axis. In other words, it looks like it's taking a game controller and it's taking the vertical axis of the joystick, and I've got a formula unit that's saying multiply A times B. So I'm going to multiply these two things together. So what is this other B that it's multiplying? Well, it looks like it's speed. So I made a variable, an object variable called speed, and the default value is 1. So it's going to multiply whatever vertical input you give it. So in other words, a value between -1 and 1, and you multiply it by speed. And then you take the output and you feed it into a translate node to the Z component of the translate node. That means, in essence, you're moving whatever object you're controlling forward along its Z axis. Okay, but what else does it do? Well, as the flow of control continues to the next node, looks like I'm doing another get axis, but this time horizontally. So I'm taking the joystick's horizontal position, and again I'm multiplying A and B together. But what's the B I'm multiplying? I've got another variable called rotation speed. And here's the variable, rotation speed. It's also by default set to 1. And so this means that whatever I do to the joystick left and right, I'm going to rotate how much I push on the left and right joystick against this rotation speed business. And I'm going to feed that output into a transform rotate node, but feed it only to the Y component, because the Y component is the vertical component of your object. In other words, I want to turn on the vertical component. So basically, by implementing this, I've got the ability to drive a little character around on the screen, moving forwards, and also actually moving backwards, because the joystick will give you negative values, and also turning left and turning right. This would be the equivalent excuse me, C# codes. So you've got input.getAxis vertical multiplied by speed, input.getAxis horizontal multiplied by rotation speed. Save it into those variables, and then transform.translate 0, 0 translation, feeding it to just the y component. Transform.rotate 0, rotation 0. Remember, we wanted to rotate around the y-axis, so x, y, z, so we put it in that space. Okay. You can ignore this part for now. We can talk about this in class at another time. Okay, so what about dynamically creating a game object? So when is this useful? Well, most of you like to write video games where you shoot things or spawn things. Well, basically, this is about spawning. In Unity, it's called instantiating. Okay, so this would be the C# codes for instantiating something. So to instantiate something, you need to take the original game object. You need to give it the position where you want the object to spawn, to instantiate, and then you want to give it the orientation. And the orientation is typically given as a quaternion. So I'll say quaternion.identity to reset the rotation angle to the identity. In other words, 0, 0, 0 rotation. The equivalent visual scripting design would be something like this. You would have the instantiate node. You got to feed the position. In this case, I'm feeding it 1, 2, and 3. So here it is, 1, 2, and 3. And then for rotation, I'm using this quaternion identity business. So I would take quaternion Euler converter node, plug in 0, 0, 0s because I want identity, and I can feed the output directly into the rotation. I'm taking this node, this variable, and I'm cloning this game object. So I'm going to get the variable from the object, a game object, and I'm going to feed it directly into the input of the original object that I'm cloning in the instantiate component. Okay, how do I destroy something? Well, you kind of saw that already in a previous example. You just use the destroy node. And you feed it whatever object you want to destroy. In this example, I'm destroying myself as the game object, so I say destroy this in C#. And in visual scripting, you create the self node and you feed yourself into the input of the destroy node and it will destroy you. Ha ha ha. Okay, what about collision detection? Now, collision detection basically means when one object collides with another, you want to be alerted to it and then you want to do something as a response to it. Like, for example, if you collide into an object or collide into a wall and you want to make a sound like clang, right? So first of all, to get started, for whatever object you want to do collision detection on, you need to make sure you have a rigid body component added to your game object. And then you also need a collider component added to your game object. Okay? So what you do is all the work is done by this on collision enter unit, this node right here, which means that whenever you've just entered the collision of the two objects, you can do something with it. And so when this happens, in this example, I'm going to take the flow and feed it directly into this audio source object called play one shot, which basically means play the sound once. And the sound that you play, I can pass in as a variable called clang sound, and I feed that as the actual sound file to play, right? And this is the actual audio clip. And so when you collide with something, this will simply invoke this play one shot and it'll play that sound. Here are a bunch of videos also you can follow up on to see collision detection in greater detail. You really have to understand collision detection well to use it properly. So I highly encourage you to look into these videos to understand it more deeply. Okay, physics. So one of the wonderful things about modern game engines is that physics is built in. It didn't used to be that way. It used to be that if you wanted physics in your game engine, you had to go find a physics library, or even worse, you would have to write all the physics from scratch. When I was a grad student, basically I had to write all my physics from scratch. As I mentioned before, to get the physics going, any game object that wants to participate in being impacted by physics in the game engine has to have a rigid body component and a collider component. And then if you want to move an object based on physics, Unity has a rigid body add force node, which basically means push something, add a force, nudge that object along. And the force you can specify in X, Y, and Z as well. So, you can basically apply a force in any direction that you want. It also has settings for the type of force that you want to apply. Now, the equivalent of force for rotation is called torque, which means you apply a rotational force. Okay? And Unity has a rigid body add torque node. You give it the X, Y, and Z torque values. And then you can also select the different modes of torque. You can either control the force, the acceleration, the impulse, or velocity change. Okay, we're almost at the end. I want to talk a little bit about commenting in script graphs, because when your code starts getting really big, it starts to look like spaghetti. So one of the things that Unity lets you do is that you can use the control key to click and drag and lasso units, and then you can add a comment. So on the Mac, you use the command key. So you can click and drag, for example, this part of it, and then this box will pop up around it where you can actually type some comment so that you can remember, oh, this is what this does. It randomizes the starting position of an asteroid. Okay. So the other thing you can do to help manage the complexity of this is that, remember, you can write visual scripts and multiple visual scripts, and you can put them into multiple game objects. Or you can put multiple visual scripts into a single game object. So you can divide and conquer. You can write simpler visual scripts to do different things. Okay, well, that's the end of our very quick video on visual scripting. So hope you found that useful, and try out the simple demo that I showed you, and also look into the URLs for the documentation and the tutorials that Unity has provided already in greater detail for how to do visual scripting.